Startuprad.io, your podcast and YouTube blog covering the German startup scene with news, interviews, and live events.
Hello and welcome everybody. This is Joe from Startuprad.io, your startup podcast and YouTube blog from Germany, as well as the backing podcast for Startup.radio, the world's #1 tech entrepreneurship radio. If you're listening to us for the second or third or more times, please make sure you hit the like and subscribe button wherever you're watching this and wherever you're listening to this. Guys, we are bringing you content from Germany, Austria, and Switzerland, but this time I met somebody at the Huawei Connect in Paris. And actually, I made a little exception because once or twice a year we have startups from abroad, meaning outside of Germany, Austria, and Switzerland. And this time we have Simone here from beautiful Italy, originally from Venezia, I've heard.
It's a pleasure to be here, of course, and thank you for your invitation.
Totally my pleasure. We already cleared out the weather because outside it is snowing for the first time this year in Germany. We are expecting something around 10 centimeters here. For the Americans, that's 4 inches. And everybody from Colorado says 4 inches. We get that in September. But for us here, it's almost like a blizzard. So that's why I'm prepared. I have my peppermint tea here. You have your tea there, and hopefully your heating stays on. We already talked about that as well. As I said, we met at Huawei Connect. There has been a lot of talk about SME topics, digital transformation, cloud, and AI. And actually, I also tried the AI Pango model. I was pretty impressed because I was talking to it in German and really fast. And my German name is Jörn, J-O with the 2 dots on it, R-N, and without a hinge, it translated it. And I was really, really impressed because there's a lot of big cloud providers who don't get this. What did you take from the event? What was some of the highlights, some of the ideas you took away with you?
Oh yes, it was very amazing event. We had the chance to see a lot of solutions that are moving from the on-premise solution to the cloud approach to actually exploit the power of cloud computing. That is something that we can start to think about because we need more and more computational power, so the cloud is a solution to balance and not to waste resources, because we can't just have this kind of virtual environment on the cloud that are scalable, that we can use on demand and not waste, of course, resources that maybe we don't need in their full power. And also there is a very strong approach, a very strong idea on digitalization, because yes, the consumer are very on the edge with the new technology. They use a lot of new technologies. Everyone is using ChatGPT, this cutting edge natural language processing technology, but we forget that maybe the industries, especially the small and medium industries, are still behind. They're using a lot of more traditional, a lot of handmade processes in their production lines. So I saw a very strong direction, a very strong, intention to bring the digitalization to the industry.
Actually, I have to admit, just recently, I saw some SMEs still using floppy disk, moving it from computer to computer. So there is a lot of improvement to be done here. Not too recently, I saw SMEs here in Germany moving data with floppy disk from A to B around. So I think there's a lot to do, as you've been talking about the processing power of cloud. Personal feeling is that there's a lot of digitalization to be done, but also moving on-premise stuff into the cloud, where I have to admit a few of the very long-time entrepreneurs are still a little bit frightened of, but I get the feeling that Germany, especially the SMEs, are a little bit behind the curve here. How is your gut feeling in Italy right now?
Yes, also in Italy, I can say that the industry environment in Italy is mainly small and medium size, and they still use a more artisan approach when in their production processes. So yes, I can say that we are behind. Also say behind German. We strongly have this kind of tissue made of small and medium-sized industry, and it's very difficult for a small and medium-sized industry to see the value that the digitalization can bring to the processes. And also the cloud is seen as a way to take your data outside your industry, your plant, and not as an advantage. So this is a point that we have to work a lot, because cloud is not meaning taking your data and moving them outside your plant. Is moving them in a more secure storing system, a more reliable storing system. You can access to much more powerful processing, computing, and this is the point where we have to. We have to point the most when we talk to our clients, to our customers.
Just to make sure, if you're talking about secure storage, you're talking about digital storage and not stone tablets, right?
Oh, yes.
Just to make sure. Before we get a little bit into what you guys are doing, I've seen you did some very impressive stuff. I have to admit, I don't understand a lot because my Italian is, so to say, non-existent. but I do get that you studied at Padua, and
Yes.
then you did some type of internship. Then you've been with an information technology company, and then you already started at Tensor. Can you take us a little bit along the journey for 1 or 2 minutes and what you've learned there, so people understand from whom they are getting the good advice?
Yes, of course. Yes, I graduated at the University of Padua in telecommunication engineering, and during my master degree, I had an internship in a consulting company of information technology in Milan. And then when I graduated at the university, I took maybe a few months to go around the world. I stayed in Thailand, and I enjoyed the time to just organize my ideas on my future. Then I came back and I moved to Trento. I started working in Tensor. When I moved to Tensor and I started my journey, it was still, because Tensor was born in 2018 as a startup. Now we are almost at the end of our startup journey. But yes, we started with a strong consulting approach, and our aim is to develop tailor-made AI solution for the industry. But in the last years, we started to synthesize our experience in products. So we are developing to, let's say, platform, artificial intelligence platform, one for the computer vision and industry, and the other one for the raising field of natural language processing with ChatGPT. AI became very, very mainstream. So everyone has very high expectation on it. So we developed these two products, and we are moving from a strong consulting approach to, let's say, product-based business approach. Yes, I started as a developer, as a computer vision expert in Blue Tensor. Yes, now when we started our computer vision platform, Iris, that's the name of the platform. I started as a project manager of this platform, and I'm very proud of how it's evolving, how we are developing, and also how we are keeping it at the edge of the computer vision technologies.
Computer vision is a pretty amazing topic. We'll get right to it. But one question, when you talked about telecommunications engineer, I had in the back of my mind the main question. So every time the satellite dish of one of your relatives doesn't work, they call you, right?
Yes or no? No, actually, I chose a very, let's say, weird curriculum for my telecommunication degree. I of course attended a lot of networks, wireless networks, 5G and mobile networks courses, signal processing. So this kind of, mainly telecommunication fields, but also it was the start, of the AI. So also the university started a lot of courses about artificial intelligence or data-driven models. And I put myself into it because I was really fascinated by this kind of topics. And also, I attended a course about the application of these information technologies, both AI and data-driven models and signals processing into healthcare application. I'm actually, let's say, healthcare information technology expert. But yeah, this is my telecommunication curriculum. So it's yes, about telecommunication, about signal processing, but applied to data-driven models and, in this case, healthcare.
Mm-hmm. You are talking about AI no-code visualization. Your tool is called IRS, right?
Iris.
Yeah, Iris.
The name of the platform.
Exactly.
Yeah.
Spelled like IRS.ai. Can you first, before we get into a little bit specific stuff, can you tell us what an AI no-code visualization actually is? Because in the brain of most people right now, there's the buzzword alarm going off. Lots of buzzwords, no meaning behind it. Can you put a little bit meaning behind this for all of us?
Oh yes, Iris is our computer vision platform, and it has been designed to not require any coding expertise, any computer vision expertise, is just something that allows the industry, especially this small and medium-sized industry, to embrace, to leverage the power of AI without the need of high budget or high investment on maybe a computer vision team or data scientist team. So this is the meaning of no-code computer vision platforms. You don't need to be a developer. You don't need to be an expert of deep learning and neural network models. You just need to be an expert of your own field, of what you are, of your product, or what you are building, or what you are generating inside your industry. So this is the only requirement that you have to start using our platform.
Mm-hmm, mm-hmm. I see. And now let's talk a little bit about it. It's basically an AI. I don't have a degree in engineering. Okay, so cut me some slack here. And could I put it in very layman terms that your platform is an AI you can train that works with pictures?
Yes.
Score. Almost an engineer.
Correct. Yes. It's a computer vision platform that, of course, works with images or also video. The point is that you can start the development of an entire computer vision system. So starting from the data acquisition, data annotation, AI model training, that is one of the, the annotation and the training are one of the most difficult part of computer vision system, AI system development. And then one of the main feature of our platform is that you can, with our flow technology that we develop, you can take the model that you developed, put it inside a workflow, and deploy it inside your production line with, of course, no need of code, no need of expertise. You just have your computer vision system for, let's say, one of the main field of application is the quality assurance. So you can start acquiring your images through Iris. You annotate them through Iris, using also this technology of data annotation that allows you to be very, very fast. Also, it supports you with some smart tools, and then train the model. And finally, you can just deploy your model in your workflow, and you have your computer vision system working without, again, writing a single line of code and without having the knowledge behind the computer vision model. So you just have to have the knowledge to annotate, your products, but it's basic requirement for someone who wants to develop this kind of quality assurance.
One question when you're talking about
Yeah.
annotation, it's basically you have what I have in mind. You have a picture, you put
Yes.
some circles around several pieces, and you then tell the AI, for example, that is a good piece, there's something broken off, and we want to have it look like that. Something along those simple lines?
Oh, yes. It's something like you have your images and you have to say to the model, you start with the white model, blank model with no knowledge. So you have to say him, it, or you have to say that this is a defect, this is another defect with another name, so you can also differentiate the detection of the defects. So this is a scratch, this is another kind of defect. this not uniform color, and just with let's say rectangles, boxes around the defect, and you collect a lot of images. You, let's say, annotate in the sense that you say to the model, this is a defect, this is another defect, this is another kind of defect. You just push all your data inside the model. The model starts his training process. And at the end, you have a model that is able and very, very specialized in recognizing your defect or the defect that you provided. And not only in the images, of course, that you provided, because this is very simple, but the strength of the AI and what differentiates the AI models from traditional approaches is that the AI models are very, very good in generalizing the defects. So they just extract the features of the defect. They learn the feature of what is a defect. And then they start looking for the defect in new images and new pieces that he never seen before.
So basically, you have to do some training on the job as you would like a human person in quality insurance, but you have to dumb it down below human level as you would have speaking with a very dim-witted toaster, and you train it over time that it gets as good or even better as your best quality insurance people.
Oh, yes. You start with, usually we start with a baseline, but that is more or less at the same level of a human level quality assurance. And then with our models, we, let's say we start training the models, and you can think about the models like babies. So they cannot do a lot of things. They just can learn to make few things, but can learn to make them very, very, very good. So if you show them the defect, they start learning how the defect is made. And at the end of the process, they are, in most of the cases, they are much better than human level of quality assurance control. I mean, for more reasons. One is the bias. The human brain is strongly biased. Also, we had scenarios where the machine that is able to extract feature from the image is able to detect defects that were not detected by the human. It was very difficult to see by the humans. So we can reach a very high performance with this kind of models.
Mm-hmm. I see. And basically, when you talked about the babies, I know how you feel about your models. Let's talk briefly about how you actually apply something. Before we start the interview, you talked about an implementation you did in a biotech company producing bone prosthetics. So how you're actually using that, and then we can get a little bit back to the topic that connected us, the help of Huawei. But first, we want to have like a real world example how you could do that, because a lot of our audience, that was pretty abstract what we've been doing. But if they do get like a real feeling on what it can actually do, they start getting ideas like maybe today, maybe tomorrow, maybe after 2 beers, maybe after a dozen beers, doesn't matter.
Okay, yes, of course. We developed a very interesting project in the biotech technology. As you said, there was this prosthetics, bone prosthetic, hip prosthesis is, of course, made of a metal part and another part that is inserted inside bone. And the problem is that we have to reduce the risk of contamination of this part. are products that needs a very, very high level of quality assurance. And
for the very simple reason it goes into a human body, so no person can really touch it with a finger. Best nobody in the room, right?
Yes, of course. So the quality assurance has to be made inside a clean room. So there are solutions where the human can go inside and use the gloves and do the quality assurance, but the aim is to completely eliminate the human manipulating of this kind of objects. And so we used a cobot, a collaborative robot. So we also integrated this kind of technology that take the prosthesis, bring it in the front of the cameras so we can acquire images with different lights. Then it put it down, it take with the other side to control also the metal part. The metal part is the part that goes with the metal sphere that goes in the joint. And then we control through iris that the piece doesn't contain any defect. That is very important. They are they have very, very high standard. The pieces must not contain any kind of defect, any kind of color, different color because it means that it has not been, let's say, elaborated correctly by the human, the machine that build it. Let's say
it has to fulfill higher standards than the highly reliable machines,
Yes.
because if one of those implants is broken, you cannot just send in a senior engineer with a monkey wrench and a full cup of coffee. It doesn't work because you also have to do surgery again, and the patient
Yes,
has to
of course.
incur additional risks. So they're very high standards, right?
Yes, and also you have very, very small defects. That means that maybe the clinician cannot maybe see those defects with his eyes. And when you implant it inside the body and you start understanding that there is something wrong with it, it's too late because you have to remove it and change it, and it's not something that someone wants to go with.
Are we talking about something like microfissures here?
Oh, sorry, what?
Like micro fissures, like very, very tiny fissures, like breaks,
Yes.
like very tiny that you can
Very
usually
small
only see.
scratches. Maybe when we started with Blue Tensor, everyone was happy with millimeters defects. Now they are asking us for smaller and smaller defects. Now we are in the range of fraction of millimeters. So we have to detect very, very small imperfections in the surface of this kind of products.
My understanding is, as you said, you're already working there with the robot. So basically, the robot is taking the pictures, it gets sent to the Huawei cloud, to your model, it comes back and it says, oh, good or no good, and then it proceeds without a human ever touching it.
Yes, of course. Yes. The room is closed, so nobody can enter inside the room before the process has ended. So the cobot is able to perform all the manipulation that we need to perform the quality assurance.
Mm-hmm. I see. And now let us go a little bit back in order to like close the loop. We talked about Huawei Connect. How did those guys at Huawei help you? Because I can totally see how the person in charge of the acceleration program could help you. He's a very talkative, very energyful guy. But how did the company help you?
Oh yes, we started our collaboration with Huawei with the program we applied for a program for acceleration program where we proposed that our computer vision platform Iris that now is installed, is deployed inside on-premise servers. So the server is inside the company, inside the company network. So it's okay because everything stays inside. Also, we have limitation on computational resources. We have a limitation on easy of access because, of course, we use the standard firewall of our machines, but of course, sometimes not enough. And also, when the machine fails, it's a problem because we have a single point of failure if we have a single machine deployed inside the company. So our proposal is to move, or not move completely, but to extend our offer and move iOS not only on premise, but also as a service on cloud. So we can provide our unique features, our computer vision platform, and the ability to develop on your own your extremely customized computer vision system through the cloud without the need to buy machines, so that are kind of expensive, and also with the reliability of the cloud, the easy of access of the cloud that you can access wherever you are. You can use more sophisticated firewall system in that the cloud services as Huawei are providing us, and we can also exploit data storage because, as I said, they are asking us to detect smaller and smaller defects. That means that we have to generate bigger and bigger images to detect very, very small defects. And so we need more computational resource to process this kind of images that are very big, and also we have to store them, and we have to store them in a reliable way. So if we have to do so inside an on-premise server, we have to buy different storage to have the backup, while in the cloud it's reliable because they provide us the backup with their services, with Huawei cloud and storage backup services.
Do they also help you with some of the models?
We don't use the models, or we actually use the computational power of the Huawei servers with the to train our models and to prototype our new models, because also we want to keep Iris at the cutting edge of the computer vision technologies. So we are always trying to find new models that can perform better, or models more suitable for some scenarios. So we use the, let's say, kind of limitless power of the cloud, because it can provide you a lot of servers, a lot of GPUs, a lot of computing resources to prototype, deploy new models, and of course train models. That is another very computing resource expensive task.
Great. Simone, I would let you go because usually we talk around 25 minutes. Now we're recording for almost 35 minutes, and I can already tell your interview will be a big success, especially with ladies, because your Italian accent is amazing.
Thank you.
Also, the story was pretty interesting. We linked down here in the show notes a lot of additional links where you get additional information wherever you're watching this or listening to this. You can go down here in the show notes or to blog.startuprad.io, and there you'll find the show notes for the respective episode. Simone, only thing for me to say is mille grazie.
Grazie mille anche a te.
Great. It was a pleasure talking to me. Thank you. Bye-bye.
Thank you. Thank you very much.
That's all, folks. Find more news, streams, events, and interviews at www.startuprad.io. Remember, sharing is caring.